Hey class, we're going to cover wiring schematics and circuit testing in this lecture. Okay, so the first things that we have to understand are the colors of the wires. Now, there's no specific color when it refers to, say, um, like a signal or a power or a ground. The majority of vehicles do use red as ground as power or as positive, and they use black as negative or ground. Okay, but that is not true of all vehicles. That's how the majority of vehicles are, and that's the most common that we'll see, but that is not true of all vehicles. Okay, so not all vehicles use red for power and black for ground. I've seen some where they use black for both, for red for power and ground, and I've seen where they use, say, green for ground. I've seen that before. It's not common, obviously, but it is out there. Okay. Now, most all wiring is going to have color around it. So we don't see the copper that is sticking out. So this picture here, we see the copper that's sticking out. But that's not how we're actually going to see the wiring in a vehicle. We're going to see it as a color-coded wire. Okay. This plastic piece, the shielding or the insulation, is going to be color-coded. Now, it can be either a solid color, just blue or just brown or just red or just green. Okay. But it can also have a stripe in the middle of it. Now, if it has a stripe, the stripe is always going to come second. Okay, so the example that's given here, BRN is brown with a white stripe. Okay, and the first color, the first letter, sorry, the first acronym is always the solid color. So BRN is brown and then with a white stripe, because white is second, WHT, and they're always going to be abbreviated in some way. They're never going to say the entire word. Okay, and we'll get to that one on the next slide, or the next couple of slides. You'll see what we're talking about here. So we have a couple different abbreviations. Now, some manufacturers use 3 letters, some just use 2 letters as their abbreviations. Okay, now they don't go through every single color, like light brown, dark brown, medium brown. They just do brown for the most part. Okay, they don't have dark red, maroon, light red. It's just red. Okay, because then it gets too confusing. Sometimes they will use, say, light blue. I've seen, but it's not very common. But they do use it. Um, and I've seen light green before, but I haven't seen, say, like light purple or something, or light orange. I haven't seen that before. Okay, but some of them will use like the light color or the dark color. Say dark green, dark blue, light blue. I've seen those, but not the other ones. So the abbreviations are very simple. They're going to take, black is BK, brown is BN, red is RD, orange is OG, yellow is YE, okay, and so on and so on. Now you have some of the 3-letter abbreviations over here on this side, okay, on the left side of the screen. That, those are, I think, common in a lot of the American manufacturers. You'll see them. But again, we're just using the normal colors as far as the more traditional colors. We're not using too many of the off colors that you don't see very often, like sky blue. They're not gonna have sky blue. It's just blue or light blue. Okay. All right. And as we move on, in the wiring diagrams themselves, also, they're going to be labeled. Now, the thing about wiring diagrams, they have to be drawn in a vertical or horizontal format. So you notice that there's a wire that goes straight across, which is horizontal. Then we have a wire that goes down, which is vertical. Then we have a wire that goes back across, which is horizontal. They are not drawn diagonally, okay, or not drawn in like some weird way in some different method. It's just horizontal or vertical. That's how everything is drawn. Okay. Now, there's some labels on this diagram here, right? I mean, I think everyone can recognize the bulb, which is the electrical load over here. So that's our electrical load or our light bulb. But there's some numbers here. C210 is one of them. Now a C210 means connector 210. The 210 means something too, which we'll get to. But the C210 is connector 210. This symbol here, which has the 2 arrows, looks like they're both going the same direction. That is the connector. Okay, so this C210 is referring to this connector. Okay, we have a for the ground wire. Sorry, I'm coming to the bottom down over here. So our ground section, I assume it's ground. Sorry, it's not actually shown ground, but I'm assuming. is 0.8 BLK. So it's a black wire and it's 0.8 millimeters uh, around or in diameter, 0.8 millimeters squared. All right, that's the size of it. The wire over here, which is 0.8 ppl, is 0.8. That's also the same size, but ppl is purple. So that's a purple wire into the connector. Out of the connector, between the connector and the bulb, the wire size is the same, but the color changed. It went from ppl to ppl slash WHT, which is purple with a white stripe. Okay. So as we can see, the wiring changed from the beginning of the circuit to the end of the circuit. We're not exactly seeing power and ground, but we're just following the beginning. So here's the beginning. It is 0.8 purple, goes into a connector, comes out of a connector, still the same size, 0.8, but the color changed. Then the wire goes into the bulb and comes out of the bulb. And as it came out of the bulb, the size stayed the same, but the color changed again. So we have three different colors within this small wiring setup here. And the connector, the only one connector that is given is C210. That's the number of the connector. Okay, that's what we're referring to. Okay, now this symbol or this page here shows a lot of the available diagram symbols. It would definitely be to your benefit if you were to say pause the video now and go through all of these, go through positive, negative, battery, ground, fuse, circuit breaker, resistor, and so on and so on and so on, seeing splice and seeing wires that are not electrically connected. Okay, over here the motor and the capacitor. So all of these are going to be used in wiring diagrams, and you're going to see them over and over again as you get into more electrical circuits. Okay, again, pause this, go through this, try and memorize as many as you can, especially look at the common ones. And maybe just have a little cheat sheet next to you as you're taking quizzes and tests and stuff like that, and that'll definitely help you. It also helps you in the future, obviously, if you're going to take the lab portion of the class, then it's definitely going to help you with that as well. Here's a couple more symbols. So our symbol, which I already told you, is the connector one, which is the two arrows pointing in the same direction. Okay, they don't have to be pointing left or right, as long as they're in the same direction. That just indicates that there's a connector there at that point. So we're going back to the plastic connectors with metal terminals. Our battery, which I have drawn for you in previous lectures and PowerPoints, is listed here. So we have our power and then our negative, then our power, or sorry, positive, negative, positive, negative, positive, negative. If you want to fully draw it out, you would draw 6 long lines and 6 little lines. Okay. And then our ground symbols, the most common one used is the one on the left that I just circled. The one here that I'm pointing an arrow to, that's one is often used by Ford Motor Company. Okay. It's not very common anymore. I think Ford has even switched to this one here on the left. That is more common. Okay. But these are just some of the symbols that are very common and that we will be seeing a lot of. A couple different ones, a couple new different types of symbols here. With this symbol on the top, where it has this little bump or hump in the middle, that indicates that these wires are not connected. They cross paths, but they do not connect. The one down here, where we have a splice, this dot in the middle means they are electrically connected. So they share they share electricity. Where there's power or ground, they are shared. Okay, that's what those are indicating. Now, for the ground connectors, this is important to remember too and to understand. This really applies to American vehicles though. So this applies to the Chevy, Ford, Chrysler. It does not really apply necessarily as much to say Honda, Toyota, Subaru, Mercedes, BMW, Volkswagen. Those are not American vehicles. Kia, and Hyundai. Those are Korean vehicles, German vehicles, or Japanese vehicles. So we're talking about American vehicles. This is really what applies to. So the connector numbers indicate, or the ground numbers indicate where they are located. So if we have C201 or we have G102, that's going to tell us roughly where it's located in the area. So C201, it has a 201. If you notice, under dash is 200 to 299. So that would be located here under the dash. the G102 is located under the hood because it starts with the 100s. So anything with the 100 to 199, we're looking under the hood. 200 to 299, we're looking under the dash. 300 to 399, we're looking in the passenger compartment. And then 400 to 499, we're looking at the trunk area. Okay. And that goes for grounds, splices, and connectors. So we're looking at the 3-digit number. Where is it located? And that's going to give us a rough idea. Is it in the front, under the dash, in the passenger compartment, or in the trunk area? Okay. Now looking at this wiring diagram here, this is a very, very simple wiring diagram. I just want you to identify a couple things. So we have C2 connector 2. Okay, so it's in the ignition switch. We know where the ignition switch is going to be on the column or the dash on the driver's side. We have a wire that is yellow and it's 0.5 millimeters. Okay. We have a circuit number, which is 5 right here. Okay. We have a C220. So the 202. So 202 indicates that that is in the dash area. This connector is in the dash area. Okay. And our connector is represented by the 2 arrows. And then we have a connector down here at the bottom, C201. Okay, and 201 is going to tell us that this is is under the hood, that this connector is under the hood somewhere. Okay, and C202 is under the dash somewhere. Okay, so that's how you read this. There's more to it than that. You can see there's some other numbers and letters I didn't go over, but you can just read them here. Okay, and see exactly where they go. But I'm highlighting the most important ones, the most common ones that we're going to see. Again, if we look at this one, what color is the wire for the ground? And it would be black. Okay. What size is it? 32. So 32 millimeters squared is the size. So it's a big wire. Our G305, which is our ground number, G305 is going to be located within the passenger compartment. The other wire that goes to the ground distribution, okay, is also black in color. It doesn't tell us the size, okay, but it does tell us the color at least. Okay. So there's just a couple, again, just a couple things I'm highlighting, trying to show you, how we read wiring diagrams and how to understand them. Okay. At any time, feel free to pause the video and look at it a little more thoroughly. Now, these are just symbols for bulbs. We have single filament bulbs and dual filament bulbs. Our single filament are the most common. One bulb, one brightness. Our dual filament have 2 bulbs and 2 brightnesses. Think of a brake light that is also a tail light. A lot of trucks have this. So a truck, when they turn on the headlights, the taillights come on also, and they're a certain brightness. But when they step on the brake, the taillights just get brighter. They don't change the location. They just get brighter, and that would be a dual filament bulb. So your brake light and your tail light are the same bulb. It's just there's 2 filaments within it. One's not as bright as the other. Okay. Then we have a motor over here on the right side. And that is just a symbol for a motor. Motor is really simple. That's just telling us that we have an electrical motor in the circuit. Okay. And that is a symbol for it. A couple other symbols. We have resistors, variable resistors, and a potentiometer. Again, pause the video, look at these, draw them down, draw them. If you have a notebook and you draw it down and you label it, it definitely helps you in the future. Same thing for these capacitors. The lighter one is not used very often. I don't see this very, very often because we don't have lighters in cars anymore. We have USB outlets or charging ports now. But the charging port used to be a lighter. Okay, now we've changed it because most people don't smoke anymore. And then capacitors. Capacitors are, which we'll get into, are electronic components, and they store electricity. But this is the symbol for them. There's 2 different symbols. Okay, and that will go over more over when we get into capacitors. But for now, we're just showing you the symbols. Now, if we see a dotted line around a circuit, that just tells us that we're zoomed in. Basically, we are looking at just a portion of the circuit. We are not looking at the entire thing. We are zoomed in, so to say. Like when you zoom in on your phone to see details of something, you want to see a detail of a picture, you zoom in. That's what this dotted line is telling us, that we're not looking at the whole thing. So if you want to see the whole thing, you got to zoom out. When we see the solid box, That tells us that we're zoomed out. That means that we're looking at everything. There's no more to look at in the circuit. We're looking at the entire circuit. Okay, we're zoomed out fully. Now, when we see a solid line with a ground symbol at the bottom, that tells us that the case is ground itself. That means that the electronic module that we're looking at, the electronic component, has a physical metal case, and that metal case is grounded. So don't move it, is what it's saying. Or if you do move it, know what you're doing, that we have to connect it back up. We have to bolt it up. Sometimes on some vehicles, in order for the case to ground of the electrical component, we just bolt it to the chassis and it grounds. Okay, we don't have to run another wire. And that's what this is representing. So if we see this, that we know that the entire case of the component, the outside of it, is made of metal and it is grounded to the chassis. So here's a bunch more. Okay, a few more. Again, we keep trying to show you these because they are very important to understand and remember. The more you look at them, the more you will get used to them, and the more they'll be easier to identify. All right. Some of the most important ones are here at the bottom. So we have our connector. Okay, that's already been shown to you. Hopefully, you remember that one. Open switch and closed switch. So those are very important to understand and remember. And then obviously the fuse, I think, is a very important one to remember, just so you know what the fuses look like. We already know what ground looks like and we know what ohms looks like. But again, the fuse, the connector, open switch. Okay. So again, pause it, write these down, memorize them, whatever you have to do to be able to understand what they are. Now here we're looking at a wiring diagram that is not fully complete. And the way we know it's not fully complete is because of the dotted line. So we have these dotted lines up here around the whole case. We have a fuse block in the rear that we're looking at. We have internal lamp relay. So the relay is right here. We have a fuse, which is 10 amps. If we come down here, looks like we have a blue-white wire. We have a dark blue with a white stripe wire. We have a tan wire. We have a connector number 2. Okay. Again, I'm just getting you guys to understand how to read these. Okay. Again, some of these we're gonna have big connectors on some of these units and some of these modules, fuse boxes and stuff, and these numbers are just relate to the connector numbers. Okay. Each terminal number. So there's a connector number, there's a terminal number within the connector. Again, it gets somewhat complicated, especially when you're dealing with a connector that has 80 terminals in it, then yeah, it can get very complicated. But for the most part right now, I just want you to identify some of the common parts, some things that pop out to you right away and what you see. Okay. I don't expect you to become an expert on this right away. Now, if we get into a relay, so a relay is a component, is a electrical switch that we use on high amperage circuits. So relays are only used for high amperage circuits. And it is an electrical switch is what it is. Okay. Now there are terminals on the relay. The terminals on the relay are labeled here. So 30, 85, 86, 87, and 87A. When we get into magnetism, the relay will be discussed a little bit more, and we will discuss on how it actually works. Okay. For now, the main thing here is to understand the numbers and what they mean. Okay. So take a moment, go ahead and pause the video and write all these down and try and, look at them. And we're going to come back to this definitely when we get into magnetism. Okay. So for now, again, just write it down and look at the numbers for now. Okay. Because that's where we're looking at the diagram in this portion. Now here's our relays when they are normally open and normally closed. So normally open looks like a switch, as you can tell. So we have a switch that goes up and there's no connection. Then we have a switch here and we have an arrow that makes the connection. So this just means that it is open when in the normal position and is closed in the normal position down here at the bottom. The normal position is what most of our electrical circuits are. So just walking into a room, the switch is in the off position and the lights are off. That's all it means. Okay. The normally closed position is you walk into the room and the switch is in the off position, but the lights are on. Okay. That's very rare. That obviously that doesn't happen very often. What we would use a normally closed circuit for would be something like a daytime running lights. When you turn the ignition switch on and the vehicle is on, the lights are on by themselves. You don't have to turn any switch on. They just come on. in order for you to turn off your daytime running lights, you have to actually go to the switch and turn it off in the different position to be able to turn it off. So that would be a normally closed switch, which again are not used, a lot throughout the car. Okay, just a little bit, a couple specific instances. The relays themselves, sometimes they do have numbers on them, which is good to help you identify, and sometimes they don't. But if not, then we learn how to measure them using a meter to identify what a few of the numbers are and where they are. Okay. But the relays, again, they're going to be located usually with the fuse box. So when you pop off the cover of the fuse box, you'll see fuses and you'll also see relays. Relays are about the size of a quarter as far as like they're square in size, but they're about the size of a quarter as far as like, physical dimensions, so to say, but they're thicker. Sometimes they look like a little mini charging brick almost. But that's what they're not big components, they're small components, is what I'm getting at. And now we're looking at a relay circuit here with horns. Okay, so this is a simple circuit. We have a 15 amp fuse. We have the relay here. Now the relay, when we connect on the horn switch, so this horn switch is located where your steering wheel is. Okay, steering wheel. It looks like a peace sign, but steering wheel. Okay. So your steering wheel is your horn switch. So when you push on your airbag on your car, that's your horn switch. You're activating this switch right here. The switch, that's the switch you're activating. Okay. And that switch there will then energize the coil of the relay. It'll close the relay switch, which is right here. That'll close because this is being energized with magnetism. Then the horns will activate. Okay. I mean, obviously, this happens very, very fast. Faster, to us, it's instant, but it is happening very fast. Once the circuit is closed, once the relay is turned on, then the horns will activate. The horns are grounded by the chassis. Okay. Again, we're going to get more into this, but for now, we just want to concentrate on the wiring diagrams and how wire diagrams are to look and how to read them and understand some of the components in them. Okay. When we see, we've seen these jagged line before. That is the resistor of it. Okay, this is a relay, but it has a resistor in it, which is fine, which they do make. But then when we see this portion, looks like, mountains or something, or hills that are connected, that there, sometimes I've seen them like this too, where it looks like a coil over and over and over again. Okay, so the coil represents the coil, a winding of the relay, or the ones that look like little hills. So hills connected together, or coils, or like a circle wind. Kind of looks like a, coil winding is what it's called. So that's what we're looking at here. Okay, those are the symbols that we're going to be looking at to identify and draw relays. Okay. And again, here's another diagram of how a relay could be set up. We're going to go more into this when we get into magnetism, but again, we're just trying to look at the diagram, see what we can identify. We have fuse up here. We have a splice right here. We have another splice. We have a lot of grounds. Let's get 1, 2, 3, 4 grounds. Okay. And then we have the relay in the middle. And then we have 3 bulbs. 1, 2, and 3 bulbs. Okay. Again, just looking at things, trying to identify them. We will wire relays. I'll show you, visually how to wire a relay later in the next PowerPoint. But for now, we're just looking at the wiring diagram. Fuses can be, where they're located. So the fuses are going to be either under the hood or on the side. This is the side of the dash. If you notice down here at the bottom, there is a brake pedal. So that's where the emergency brake is, and this is on the side of the dash. You'd have to open the door to be able to see this. Okay, and that's one of the locations, one of the main locations of where a lot of the fuses are. In order for us to check fuses, we could use a circuit breaker. So I don't want to get too much into this because I know this is more diagnosis and there's more on cars type of stuff. But there are circuit breakers that we can put in place of a fuse if the fuse keeps blowing. Instead of replacing fuses over and over again, we put the circuit breaker there to pop every time there's a short circuit. Okay, and that'll save, us from using fuses over and over and over again. So we go and we look for the fault. We think we may have it. I don't know. We try and check it. We put the circuit breaker on and boom, it pops again. Okay, we didn't find it. Keep going, keep working. You keep going until you find the fault and you repair it. And then you can verify with the circuit breaker that it works without continuously using fuses over and over again. Here we have some couple different types of tools that can be used. One's a tone generator and one's a Gauss gauge. So the Gauss gauge will um, move this needle to where the short is. You physically put this gauge onto the wiring harness where you may think that the short circuit is located within the car, and you activate the circuit. Once it senses a short circuit, the arrow, sorry, the needle will go towards the arrow. Okay, it'll bounce that way to the left, so to say, or to the right, whichever direction the short circuit is in. Then you take the Gauss gauge and you move it over to the left if it bounces to the left. And then you do it again. You repeat the process and then it bounces to the left. Then you keep going, keep going, keep going until you finally find that it bounces to the right. Then you know that your fault is within the sections, the last section of the left and the first section of the right that you were able to identify. And that's what this needle is on the inside. Okay, it's going to bounce left or right depending on where the short circuit is, and you're physically moving that Gauss gauge on the wiring harness to be able to identify it. The other one's a tone generator. So I'll show you a picture of the tone generator, which I think is going to be a little bit easier to understand. So here's a tone generator. Again, if you want to go ahead and pause the video here, and you can look at this and read the verbiage that it says up top, and go through this a little bit more in detail. But the tone generator is we're going to use audio to be able to try and help us locate the short circuit. Okay, and again, this is just to help you to be able to go through the diagnosis process without just ripping everything apart and visually looking for everything. We want to get an idea of where it is first before we start unraveling the wiring harness. Unraveling a wiring harness is could be a big job, could take a lot of time. So we want to be able to at least get an idea of the location of the short to ground that we're trying to find. Okay, and this was the tone generator does this. Okay, so again, pause this and look into this if you would like to. The last the last slide we have here is how to use a test light. So this verbiage over here that's highlighted on the left, this tells you how to use a test light, explains how to use a test light to be able to find a short circuit. Okay. Again, if this is a good point to stop and pause the video and write this down, try to understand it, try to read it. Again, a lot of this is FYI type of stuff. A lot of it is, unless you're in that specific situation with that specific vehicle, it may be difficult to duplicate. But at the same time, if you know this knowledge and you have this in your head, you're like, oh, let me try this. At least you know that you can try different things. There's different tools out there, different ways to find different types of faults. Okay. So hopefully you learned a little bit from this lecture. If you like, as always, feel free to reach out to me if you have any questions. Okay. And take care as always. Thank you.